The blue whale is the largest animal that has ever lived. Its heart is the size of a small car. For as long as we have kept records, that title has not been in question. It is the last word in size. Except we may have been wrong. 200 million years ago, something in the sea may have been longer. And the proof is not a skeleton. It is a slice of jawbone thinner than a fingernail, found by an 11-year-old on an English beach. And under a microscope, that bone reveals something no champion should show. It is unfinished. The channels inside it are still open. Whatever this animal was, it had not stopped growing. So the number in the title is a floor, not a record. So how big did it actually get? That question has no clean answer. And the reason is the whole story. This codex opens on a single bone from the coast of England, and the handful of scientists trying to read it. We will trace how amateur fossil hunters turned up a giant, longer than a blue whale, is both true and misleading, a claim about length, not weight. And we will put one slice of that jaw under a lens where a study in 2024 quietly turned the number everyone repeats into a floor. The honest answer is stranger than the record. It is that we do not really know. Before we go anywhere prehistoric, hold on to that blue whale, 30 meters, close to 100 feet, as heavy as 2,000 people. As far as anyone can prove, it is the largest animal that has ever existed. Keep it in mind, it is the yardstick this whole story is measured against. Now wind the clock back more than 200 million years, to the very end of the Triassic period, a slice of deep time geologists call the Ratian. The continents are fused into a single mass. Around them washes one warm sea. Long before it had a modern name, this water is the Tethys, the ocean this codex is named for. The Triassic was the age when reptiles went back to the water and got strange. One group, the ichthyosaurs, traded legs for fins and their land shape for something like a dolphin's, tens of millions of years before dolphins existed. Most stayed modest, the size of a person, a porpoise, a small shark. But one branch, the Shastasaurids, broke the ceiling. In British Columbia lies Shonosaurus, 21 meters of it, the largest ichthyosaur anyone has a good skeleton of. For a long time, that was thought to be as big as the reptile line could go. Then the coast of England began handing over pieces of something larger. And here, the story turns into a detective case. The windswept beaches of Somerset open a window straight into the end of the Triassic. For over a century, huge curved chunks of bone had washed out of those cliffs, and nobody knew what they were. Some were shrugged off as rock. Some were filed, wrongly, as the limb bones of land-dwelling dinosaurs, because they seemed too big to have come from the sea. The largest reptile in that ocean was sitting in museum drawers, under the wrong name. The documentary version of what comes next is simple. A giant sea monster, longer than a whale, ruled the Triassic. That version only works if you never ask the obvious question: how do you know how big a thing was if you have almost none of it? Because that is the situation here. There is no skeleton. There is no skull. For an animal supposedly longer than a blue whale, what actually exists would fit on a kitchen table. The end of the Triassic did not spare the giants that built it. Around 201 million years ago, a wave of volcanic eruptions tore the supercontinent apart and poisoned the sea. It was one of the 5 great mass extinctions, and it closed the book on the giants. Nothing with that body ever grew that big again. Whatever this animal was, it was one of the last of its kind. And the question the rest of this codex answers is not really how big was it. It is, how could anyone possibly know? But there is a problem, and it is the whole reason this animal is an argument instead of a fact. Everything we know about it comes from its jaw, not the whole jaw, one bone from each side, called the cerangular, a long strut near the back of the lower jaw. 2 of them. That is the entire animal. The first turned up in 2016. A fossil collector named Paul de la Salle was walking the mudflats at Lilstock on the Somerset coast when he found a curved piece of bone more than a meter long, broken, so the whole thing was bigger still. He took it to Dr. Dean Lomax, a paleontologist who lives and breathes the marine reptiles of this era. In 2018, they published it as a careful hypothesis, a giant ichthyosaur, maybe. One bone is a single footprint. You know something huge passed by. You cannot say what. Then, in 2020, 10 kilometers down the coast at Blue Anchor, a father and daughter, Justin and Ruby Reynolds, were fossil hunting when Ruby, 11 years old, spotted a second bone in the mud. Same strut, same strange shape, a second animal. 2 of them made a species. In 2024, in the journal PLOS ONE, Lomax and his colleagues gave it a name, with Ruby Reynolds listed as a co-author, Ichthyotitan severnensis, the giant fish lizard of the Severn. It sounds absurd to name a new giant from 2 jaw struts, so it is worth being honest about how it is done. The method is called comparative anatomy, and it works like this. Imagine you find the door handle of a car you have never seen. It is huge. To guess the car's size, you find a car you do know, measure its handle, and scale up. The team's known car was Shonosaurus, the one giant ichthyosaur with a decent skeleton. Line the English bone up against the same bone in that skeleton, and it runs about 1/5 longer. Scale the rest to match, and you land near 25 meters, 82 feet, longer than the blue whale hanging from the museum ceiling. And this is exactly where a careful viewer should get suspicious. Scaling one bone off a cousin is a chain of assumptions, and each link can bend the answer by meters. Skeptics under every video on this animal say the same thing, and they are not wrong. When someone finds the rest of it, then we will talk. Here is the surprise. The scientists agree with them. They know how thin the ground is, which is why the most important work on this animal is not about how long the bone is. It is about what is inside it. And then it gets stranger. To read the inside of a bone, you have to destroy a little of it. Cut a wafer-thin slice, polish it until light passes through, put it under a microscope, and the bone starts talking. It is a bit like reading the rings of a tree. The layers record how fast the animal was growing and whether it had stopped. A master's student on the team, Marcello Perillo, took core samples from the giant jaw. If this were an old adult, he expected tightly packed bone with clear arrest lines, the marks left when growth slows and stalls near the end of life. That is not what the slice showed. Instead, the tissue was a loose, woven mesh, threaded with open channels where blood vessels had run, the exact signature of bone laid down fast, in a hurry to get bigger. The fibers were bundled in coarse layers set at angles, a build the 2024 study compared to carbon fiber, the material engineers reach for when they need something light and strong under load. Put those readings together, and the conclusion is quiet but decisive. The animal that left this bone was still growing when it died. Not an old giant at its final length, a teenager caught mid-sprint, which means the 25-meter figure everyone repeats is not the size of Ichthyotitan. It is the size of an Ichthyotitan that had not finished yet. This is the detail almost no telling of this story includes. The number is not a ceiling. It is a snapshot, taken partway up, and it flips the headline inside out. Longer than a blue whale stops being a bold claim about a finished animal and becomes something humbler and honestly more unsettling, the smallest this creature could have been. The adult, the one nobody has found, is a blank the fossils will not fill. Those even larger, more broken bones from the old Ost cliffs hint that some individuals may have pushed past 30 meters. But that is an estimate stacked on an estimate, and the honest scientists say so out loud. Here is the part that trips people up, including the people making videos about it. When a headline says this animal was longer than a blue whale, your mind fills in a blue whale, that vast, deep, barrel-chested bulk. That picture is wrong. The comparison is about length, and length alone. A blue whale is heavy because it is built like a fuel tank. An ichthyosaur is built like a spear, long, narrow, muscled for speed, a biological missile. Line them up, tip to tail, and the ichthyosaur is still by far the lighter animal. That is why the weight figures pinned to it swing so wildly, from a slim few dozen tons to a bloated 200 or 300. Those are not measurements. They are guesses, and each one depends on which cousin you borrow the shape from. Assume a barrel-bodied build and the number balloons. Assume the slender, speed-built shape most ichthyosaurs actually had, and it drops fast. Nobody can prove which is right, because the body is missing, but slender is the better bet. The blue whale, by contrast, has actually been weighed at up to 190 tons of solid bulk. Even a record-breaking Ichthyotitan was likely a fraction of that. So the honest scoreboard reads like this. In a contest of length, this reptile is a real contender and may even win. On a scale, the blue whale wins, and it is not close. Two different peaks, two different answers to the same problem. Which leaves the question the whole thing has been circling. Why does a reptile get that long at all, when nothing since has managed it in that shape? The answer is about food. A blue whale can reach its size because the modern ocean is stuffed with krill, and the whale grew a filter to strain them by the ton. That is a very recent kind of sea. The Triassic Ocean had no such buffet. The dense krill swarms that feed a blue whale are a recent invention, and ichthyosaurs never grew a filter anyway. They had cone-shaped teeth and jaws built to seize, so the only road to that length ran through hunting, taking large, powerful prey and carrying a warm-blooded, high-output engine to drive a body that size. The chemistry locked in ichthyosaur teeth, measured in a 2010 study, points the same way. They ran warm, more like a tuna than a modern lizard. That is the honest frame, and it comes with a warning label. We are not filming this animal hunt. We are reading its habits off the shape of its teeth and the chemistry of its bones, and reasoning forward. It was almost certainly a hunter, not a gentle giant. Past that, the ocean keeps its own counsel. The largest animals in the fossil record are often the ones we understand the least. So, how big was the largest sea monster that ever lived? After all of it, the honest answer is a shrug in a lab coat. Longer than a blue whale, most likely. Lighter, almost certainly. And beyond that, we do not know, and may never. Go back to that slice of jawbone under the lens. Thinner than a fingernail, its channels still open. That slice is the entire case. It is the reason anyone can say longer than a blue whale at all. And, in the same breath, the reason that claim is a floor and not a finish line. The animal it came from had not stopped growing. 25 meters is only the largest we have caught it being. The real adult is a number the fossils refuse to give up. And that is a better story than the one the headlines tell. A finished, weighed, cataloged giant with a number on a plaque would be a fact you file and forget. What we actually have is stranger. A giant known almost entirely from two struts of jaw and the mesh inside them, that we can prove was still getting bigger, and whose true size sits in a gap no one has closed in 200 years of looking. The team reading this jaw could have rounded up to a headline. Instead, they cut the bone open and let it tell them, in the language of vessels and fibers, that the honest answer was, not yet. The scientist who named it put it plainly. Maybe one day, a whole skull turns up. You never know. There is a real humility in that. We like to think the fossil record hands us monsters fully formed, ready to rank. It rarely does. It hands us fragments and asks us to be honest about what they can and cannot say. A season ago, this codex followed a whale we had been wrong about for nearly 2 centuries. This one may be the giant we are the most wrong about, not because the science is bad, but because the animal is barely here. The largest sea monster that ever lived may still be out in the rock, unfound, and larger than the number we keep repeating. We built the blue whale's record by weighing it. We may never get to weigh this one. The jaw is a floor, and the ceiling is still missing. Ichthyotitan reached for the size of a whale and left us almost nothing to measure. But it was not the first giant this ocean built. Wind back another 250 million years, into an ocean with no fish worth fearing, and you find a hunter as long as a great white shark rising out of the gloom. No skeleton, no jaw to scale, just a long, straight shell and a crown of arms. A giant cousin of the squid, ruling the top of the food chain in a nearly empty sea. And like Ichthyotitan, it left us only the hard part, the cone it built, and none of the animal that lived inside it. How do you become the biggest predator in the ocean when you are, essentially, a boneless tube of muscle? That is where the Codex turns next. Tethys Codex.